Assalamu alaikum. Today we are going to start lecture number 34 for the classical mechanics for BS 5th. The course code of classical mechanics is PHY 509. Today we are going to complete the previous problems related to the rotational dynamics and the kinematics of rigid body. We have discussed the topics under the kinematics of rigid body and the rotational motions of the rigid body, in which we discussed about the angular displacement, angular velocity, angular acceleration, and then we discussed the relation between the translational and rotational motions. After that, we discussed the conservations and moment of inertia of the rigid body and the work and power done by the rotational objects. Now we're going to work out the problems related to the rotational dynamics and the kinematics of the rigid body. There is the first example. The angular displacement theta of the wheel is given by theta is equal to 5t square minus t, where theta is the in radian and t is in seconds. The diameter of the wheel is 0.56 meter. Determine, we have to find out number A, the angle theta in degree at time 2.2 second and 1.8 second. Number B, the distance that a particle on the rim moves during the time interval, the total distance covered by the particle. Number C, the average angular velocity in radians per second and in revolution per minute between the 2.2 second and 4.8 second. We have to calculate the angular velocity in radian per second and in revolution per minute. In the last D point, the instantaneous angular velocity at time 3.0 second. Now starting with this solution, we have r is equal to radius is equal to d by 2, that is diameter by 2. Then this will give 0.56 over 2 is equal to 0.28 meter. At time, first of we are going to find out the point A at time t is equal to t1 is equal to 2.2 second. We are going to substitute the value. We have theta 1 is equal to, we have the theta value, so we are going to find the first theta 1 value with the time t1. Substituting the value, we have 5 into 2.2 into whole square minus 2.2, that gives theta 1 is equal to 22 radian. Now theta 1 is 22 radian. We are going to convert it into degree, that is 180 degree divided by pi radian, that gives 120 1261 degree. Now time t2 is 4.8 second. We are going to do the same process, that is 0 theta 2 is equal to 5 into 4.8 whole square minus 4.8, that gives 110 radian, and by that 110 radian we are going to convert into degree. We have into 180 degree over pi radian, that gives 6303 degree. Now we have the radius 0.28 meter. So find the point B by applying the equation of length, arc length, we have S is equal to r theta. So we have found the value of theta. We're going to substitute here, that is del S is equal to r del theta. So we know that del theta is equal to theta 2 minus theta 1. So we're going to substitute the values. We have del S is equal to, we have to find the distance between the two time displacements. So del s is equal to 0.28 into 110 minus 22, and after solving that gives del s is equal to 24.6 meter. The third point C is the average angular velocity in radian per second is given by, we have angular velocity, average angular velocity del theta over del t, that gives theta 2 minus theta 1 over t2 minus t1. Then substituting the values we get omega average is equal to 110 minus 22 over 4.8 minus 2.2, that gives omega average is equal to 33.9 radian per second. Converting that angular velocity in revolution per meter, so we're going to multiply by omega average is equal to 33.9 radian over 1 second into 1 revolution over 2 pi radian into 60 second over 60 second over 1 minute, that gives omega average is equal to 324 revolution per minute or 324 rpm. Now to find the part D, the instantaneous angular velocity as a function of time is omega is equal to d theta over dt, that gives omega is equal to d by dt into 5t square minus t. After differentiating we get omega is equal to 10t minus 1. So substituting the value at time t is equal to 3 second. So we have 10 into 3 minus 1, that gives omega is equal to 29 radian per second. Now starting the example number 2, a driver makes 2.5 revolutions on the way down from a 10-meter high platform to the water, assuming zero initial vertical velocity. Calculate the diver's average angular rotational velocity during the dive, and we have given g is equal to 9.81 meter per second square. You can see the picture, the height of the platform from the platform of the water is 10 meter, and he is going to dive. So the initial velocity uy at vertical height is 0, and theta initial displacement is 0, and the final displacement is said to be 2.5. Final displacement, angular displacement is 2.5 revolution, and in the water. Now we have to find the values. Theta 1 is equal to 2.5 into 2 pi, that gives 5 pi radian. From diagram SY, the vertical height is minus 10 meter. So we have the formula S is equal to SY is equal to UYT minus 1 over 2 GT square. Substituting the value we get T is equal to minus 10 is equal to 0 minus 1 by 2 into 9.81 into T square, that gives, after solving all the equations we get T is equal to 1.43 second. Therefore, the diver's average angular velocity is omega average is equal to theta 1, that is the final displacement, minus theta naught, that is the initial angular displacement, divided by time, that is t. Omega average is equal to 5 pi minus 0 over 1.43. After solving this by substituting the value of pi, multiplying and then dividing, we get omega average is equal to 11.0 radian per second. Now starting with the angular, you have to complete that numerical. Now moving to the next problem of the angular accelerations. Now starting with the example number 3, the instantaneous angular velocity omega of the flywheel is given by omega is equal to 8t cube minus t square, where omega is in radian per second and t is in seconds. Determine, we have to find the average angular acceleration between 2.2 second and 4.8 second, and the instantaneous angular acceleration at time 3 second. That is similar work previously done. The same steps are going to be used here to find the values. Solution, we have time t1 is equal to 2.2 second, omega 1 is equal to 8 into 2.2 into 3 power 3 minus 2.2 whole square. omega t is equal to 80.3 radian per second, and t2 is equal to 4.8 seconds. That gives omega 2 is equal to 8 into 4.8 whole power 3 minus 4.8 whole square. After solving, that gives 862 radian per second. Therefore the average angular acceleration is alpha average is equal to omega 2 minus omega 1 over t2 minus t1. After substituting the values, we have alpha average is equal to 862 minus 80.3 divided by 4.8 minus 2.2. That gives, after solving, alpha average is equal to 301 radian per second square. The B part, the instantaneous angular acceleration as a function of time is alpha is equal to d omega by dt. By substituting the value of omega, we have alpha is equal to d by dt into 8t cube minus t square. Alpha is equal to 24t square minus 2t, and for time 3 second we have alpha is equal to 24 into 3 whole square minus 2 into 3, and that gives alpha is equal to 210 radian per second square. Now starting another example. Exercise is first part is question number 1. If a disk 30 centimeter in diameter rolls 65-meter long a straight line without slipping, calculate number A, the number of revolutions would it make in the process, and the part B is the angular displacement would be through a speck of gum on its rim. Now we're going to do this same process and same step done previously, and you have to give the answer of 69 revolution and 138 pi radian. The second is, during a certain period of time the angular displacement of the swinging door is described by theta is equal to 5 plus 5.00 plus 10.00 t plus 2.00 t square, where theta is the in the radians and t is in seconds. Determine the angular displacement, angular speed and angular acceleration at time t is equal to 0 and time t is equal to 3 seconds. That is the similar steps done before already. You can get the help from there, and you have to take the answer, get the answer 5.00 radian, 10.0 radian per second, 4.00 radian per second square, and 53 radian, and 22 radian per second, and 400 radian per second square. Now we have to find the relationship between the linear and rotational motion problem. The first example is a car is traveling with a velocity of 17 meter per second on a straight horizontal highway. The wheels of the car has a radius of 48 centimeter. If the car then speeds up with the acceleration 2 meter per second for 5 seconds, calculate the number of revolutions of the wheel during this period. We have to find out number of revolutions during that time period. Number B is the angular speed of the wheels after the 5 second. Now starting with the solution, that is initial velocity 17 meter per second and the radius is 40.48 meter, that we have converted centimeter into meter. A is 2 meter per second, that is the acceleration. T is the time, 5 second. Now the initial angular velocity is u is equal to r omega naught. So going to substitute the value and we get that omega naught is equal to 35.4 radian per second, and the angular acceleration of the wheel is given by a is equal to r alpha. 2.00 is equal to 0.48 alpha, that gives alpha is equal to 4.17 radian per second square. Now we have the value of u, r, acceleration and time. Now by applying the equation of rotational motion with constant, we have theta is equal to omega naught t plus 1 over 2 alpha t square, that is theta is equal to 35.4 into 5 plus 1 over 2 into 4.17 into 5 whole square. Theta gives 229 radian. and therefore theta is equal to 922 radian into 1 over revolution over 2 pi radian, that gives 36.5 revolution. Number B is the angular speed of the wheels after 5 seconds is omega is equal to omega naught plus alpha t. By substituting that values we get omega is equal to 56.3 radian per second. Now the another example is the wheels of bicycle make 30 revolutions as the bicycle reduces its speed uniformly from 50 km per hour to 35 km per hour. The wheels have a diameter of 70 cm. A. Calculate the angular acceleration alpha if the bicycle continues to deaccelerate at this time. Determine the time taken by the bicycle to stop. So we have theta is equal to 30 into 2 pi, that gives 60 pi radian, and the radius is 0.70 over 2. The 0.70 is the diameter, so that gives 0.35 meter, and u is equal to 50 kilometer over 1 hour into 10 power 3 meter over 1 kilometer into 1 hour on 3600 second, that gives 13.9 meter per second. And v is equal to 35 kilometer over 1 hour into 10 raised to power 3 meter per kilometer into 1 hour over 3600 second, that gives outer solution 9.72 meter per second. So we're going to start this solution. Number A, the initial angular speed is the of the wheel is u is equal to r omega naught. 13.9 is equal to 0.35 mega naught, that gives omega naught is equal to 39.7 radian per second. And the linear angular speed of the wheel is v is equal to r omega into that gives 9.72 is equal to 0.35 omega into omega 27.8 radian per second after solution. Therefore omega square is equal to omega naught square plus 2a theta. By solving this we get 27.8 square is equal to 39.7 whole square plus 2 alpha into 60 pi, and that gives a alpha is equal to minus 2.13 radian per second. uh, v is equal to r omega 9.72 is equal to 0.35, that gives omega is equal to 27.8 radian per second. Therefore omega square is equal to omega naught square plus 2 alpha theta, that gives 27.8 whole square is equal to 39.7 whole square plus 2 alpha into 60 pi, that gives alpha is equal to minus 2.13 radian per second. And the part B, car stops at omega is equal to 0 and omega naught is equal to 27.8 radian per second, and substituting the value in the equation omega is equal to omega naught plus alpha t, that gives t is equal to 13.1 second. Moving to the example number 6, a blade of ceiling fan has a radius of 400 meter in rotating about a fixed axis with an initial angular velocity of 0.150 revolution per second. The angular acceleration of the blade is 0.750 revolution per second square. Determine the angular velocity of after 4 seconds. The number of revolutions for the blade turn in this time interval. Number C, the tangential speed of the point on the tip of the blade at the time t is equal to 4 seconds. The magnitude of the resultant acceleration of the point on the tip of the blade at t is equal to 4.00 second. Now moving to the solution, r is equal to 4 meter, omega naught is equal to 0.150 into 2 pi is equal to 3.00 pi radian. Alpha is equal to 0.750 into 2 pi is equal to 1.50 pi radian per second square. T is equal to 4 seconds, that gives omega is equal to omega naught plus alpha t. After substituting that values we have omega is equal to 0.300 pi plus 1.50 pi into 4.00, that gives omega is equal to 19.8 radian per second. Now for the solution, part B, the number of revolutions of the blade is theta is equal to we're going to write the equation of motion, angular motion. Theta is equal to omega naught t plus 1 over 2 alpha t square. Theta is equal to, we're going to substitute the value of omega naught, that is 0.300 pi, and the value of time t is 4.00 plus 1 over 2 into the value of acceleration is 1.50 pi into 4.00 whole square. We substituted the value of t. Then after calculating that, we get theta is equal to 41.5 radian. Now converting that radian into the revolution, we write theta is equal to 41.5 radian into 1 revolution divided by 2 pi radian. That is how we convert the radian into revolution. So that is equal to 6.61 revolution. 6.61 revolution. Now the tangential speed of point is given by, for the part C, v is equal to r omega and v is equal to 0.400 into 19.8, and multiplying this gives us v is equal to 7.92. The magnitude of the resultant acceleration is a is equal to under root ac square plus at square, and acceleration is equal to under root v square over r whole square plus r into r alpha whole square. We substituted the value of ac, that is v square over r, and at, that is r alpha. We have v 7.92 and r is 0.4, and substituting the value and taking whole square plus 0.4 into 1.50 pi whole square by multiplying and taking the under root, we have a is equal to 1.57 meter per second square. Now another example, calculate the angular velocity of the second hand, minute hand, the hour hand, and the of the clock state in radian per second. And the part D, what is the angular acceleration in each case? For that solution, part A, the period of second hand of the clock is t is equal to 60 seconds. Hence omega is equal to 2 pi over t, as we know that omega is equal to 2 pi f and f is equal to 1 over t. So we substituted the value of f, that is 1 over t, that gives 2 pi over t, and substituting that value we get 2 pi over 60. Then putting the value of pi and multiplying and dividing, we get omega is equal to 0.11 radian per second. That is the answer of the first part A, that is the second hand. Now for the minute hand, the period of minute hand, the time is t is equal to 60 minutes, and we know that to convert into second we multiply 60 by 60, so that is 3600 second. Substituting the value in the place of t, that is 3600, so omega is equal to 2 pi over 3600. Then substituting the value of pi and dividing, multiplying and dividing, we get omega is equal to 1.74 into 10 raised to the power minus 3 radian per second. The period of hour hand of the clock is t is equal to 1200, so we write 12 multiplied by 3600, that we get 4.32 into 10 to the power 4 second. So the omega is equal to 2 pi over 4.32 into 10 to the power 4. So that gives angular velocity omega is equal to 1.45 into 10 to the power minus 4 radian per second. That is the angular velocity in each case of the second hand, minute hand, and hour hand. The angular acceleration in that case, in each case, will be equal to 0. That is constant, because it is constant, so all the terms are 0. Now, another example, a coin with a diameter 2.40 centimeters dropped on the edge on a horizontal surface. The coin starts out with an initial angular speed of 18 radian per second and rolls in a straight line without slipping. If the rotation slows down with an angular acceleration of magnitude 1.90 radian per second square, calculate the distance traveled by the coin before coming to rest. We have a picture here. The diameter of the coin is d is equal to 2.40 into 10 raised to the power minus 2 meter, and the initial velocity omega naught is 18 radian per second. Angular acceleration is 1.90, and negative sign shows that it is reducing angular acceleration, and final angular velocity is 0 radian per second. The radius of the coin can be calculated at r is equal to d by 2, that is equal to 1.20 into 10 raised to the power minus 2 meter. uh, we substituted the value of d, that is 2.40, and dividing by 2 gives 1.20 into 10 raised to the power minus 2 meter. The initial speed of the point at the edge of the coin is u is equal to r omega. U is equal to, putting the value of r, 1.20 into 10 raised to the power minus 2, and omega naught is equal to 18. Multiplying, we get u is equal to 0.216 meter per second, and the final velocity v is equal to 0 meter per second. The linear acceleration of the point at the edge of the coin is given as a is equal to r alpha, and substituting the values, a is equal to 1.20 into 10 raised to the power minus 2 into minus 1.90, a is equal to minus 2.28 into 10 raised to the power minus 2 meter per second. That negative sign shows that acceleration is decreasing. Therefore, the total distance traveled by the coin is v is equal to u square plus 2as. We get 0 is equal to 0.216 whole square plus 2 into minus 2.28 into 10 raised to minus 2 second. After solving that, we get s is equal to 1.02 meter. That is the total distance traveled by the coin from the initial point to the final point. Now, another example, a disk is 8 centimeter in radius, rotate at a constant rate of 1200 revolution per minute about its central axis. Determine its angular speed, tangential speed at 0.3 centimeter from its center, the radial acceleration of the point on the rim, and the total distance at a point on the rim move in 2 seconds. I have told in the previous example, so all the formulas being used here, so you can use all the values and formulas so to find the part A, B, C and D, and the answer should be for the angular velocity or speed, that is 126 radian per second, and the speed should and the value of the speed at the that is 3.77 meter per second, and acceleration value 1.26 into 10 raised to the power 3 meter per second square, and the total distance is 20.1 meter. You have to solve this and complete the example. The another example is a 0.35 meter diameter grinding wheel rotates at 2500 rpm. Calculate its angular velocity in radian per second and the linear speed and the radial acceleration of the point of the edge of the grinding wheel. So for the angular velocity, the answer should be 262 radian per second. You have all the values here of diameter and the angular speed. Though then you have to calculate the angular velocity and the linear speed and the radial acceleration. The linear velocity should be 46 meter per second. Linear speed should be that, and the radial acceleration should be 1.22 and it's about 4 meter per second square. You have to calculate it by yourself. Moving to another example, a rotating wheel required 3 seconds to rotate through 37 revolution. Its angular speed at the end of the 3-second interval is 98 radian per second. Calculate the constant angular acceleration of the wheel, that is you have to calculate the constant angular acceleration. The answer should be 13.6 radian per second square. A wheel rotates with constant angular acceleration of 3.50 radian per second square. If the angular speed of the wheel is 2 radian per second and t is equal to 0, through what the angular displacement does the wheel rotate in 2 seconds? First thing is to find out the angular speed, and part B is through how many revolutions has the wheel turned during this time interval. we have to calculate the revolutions. And in part C, what is the angular speed of the wheel at t is equal to 2 seconds? The answers for that should be 11 radian, and for the revolution that should be 1.75 revolutions, and the angular speed should be in 9 radian per second in your answer. You have to do complete these examples by yourself. A bicycle is being tested at a repair shop. The angular velocity of the wheel is 4 radian per second at time t is equal to 0, and its angular acceleration is constant and equal to minus 1.20 radian per second square. A spoke OP on the wheel coincides with the positive x-axis, as you can see in the picture, at time t is equal to 0 as shown in the figure. Here is a wheel that have two axes x and y. The uh, spoke of the wheel coincides at the x-axis at the point P, and you can see that is in anti-clockwise direction rotation. You have to find the wheel's angular velocity at t is equal to 3 seconds, and what is the part B. In part B, what angle in degree does the spoke OP make with the positive x-axis at this time? You have to find the angle using all these values and the uh, Pythagoras theorem. You have to find the value of the angle. For that, your answer should be 0.40 radian per second for the angular velocity, and the angle for the angle, that is 18 degree. You have to complete that example. Now we are going to start the problems related with the equilibrium of a rigid body. Now moving forward to the problems. Determine a resultant torque of all the forces about rotation axis O in the following problems. You can see a picture here. We have a center point O at which the force F3 is being applied at the value of 20 Newton. The above and below of that block, from that center, the half of the distance is 3 meter above and 3 meter below. The width of that block is from the center, the partition of that, or the dividing that width into two parts, that is 5 meter and 5 meter whole length. At the center of the block, the force at the that block is F2 is equal to 10 Newton in the upward direction, and in the horizontal the force is F1 30 Newton. So you can say the width of the block is 10 meter and the height of the block is 6 meter, and the O point is at the center. So uh, from the center we make a line, dotted line, in the horizontal and vertical, and we have three forces F1, F2 and F3 being applied on that block. Now from the picture, the part B, you have to calculate the width is 10 meter and the length is 6 meter, and that point is at the center of the block, and the force F2 is in on the block on the point O, and there is an angular force F4 at the value 25 Newton and making an angle alpha here, and the horizontal force in positive x direction is F1 is equal to 30 Newton, and at the from the center the F3 force is being applied with the angle beta, that is 20 Newton. Working with that, we have to find the part B. Now taking the first exam part A, the diameter of the block is d1 is equal to, or the display distance of that block divided into four parts, equal parts. D1 is 3 meter and D2 distance is 5 meter. All the values are F1, F2 and F3. So we have F1 torque, that is equal to torque is equal to Fd, that is Fd is equal to Rf sin theta. So substituting that value, minus into minus 30, that is the force F1, into 33 is equal to minus 90. F2 is equal to positive 10 into 5, that is plus 50, and F3 is equal to 0. The resultant of the torque is minus 90 plus 50, that is minus 40 Newton meter, and that torque is in the clockwise direction. Calculating the part B of the numerical, we have the angle beta extended towards the point O, that is beta. Internal and external angles are same, that is the value of F320 Newton. And the D1 distance is 3 meter, and D3 is to be calculated, and F4 is 25 Newton, F1 is 13 Newton, and F2 is 10 Newton, and radius of the center to the point O of the block, that is R is equal to 5 meter. We have to calculate sine beta. So uh, by the Pythagoras theorem, we find sine beta is equal to, we have perpendicular over hypotenuse, that is 3 over under root 3 square plus 5 square. So we have 0.515. So calculating the F1 by substituting the value of angle F1 alpha, that is minus 13 to 3, that is minus 90, F2 is equal to 0, and F3, in that case F3 or sine beta, where value putting the value of sine beta, that is 20 into 5 into 0.515, that is 51.5, and F4 is equal to 0. So the resultant at the torque is 90 minus 90 plus 15 1.5, that gives minus 38.5 Newton meter. You know that the negative sign shows that the torque or the rotation is in the clockwise direction. A rod of length, total length 100 centimeter, 110 centimeter, from the central point O, uh, was is hanged at point A with the W2 weight, and at point B there is a weight of W1. Thus, from this point O to B, that is length 75 centimeter, and from point O to A, that is 35 centimeter, a hanging flower basket having weight W2 is equal to 23 Newton is hung over the edge of the balcony railing on a uniform horizontal beam AB of length 110 centimeter. The rest on the balcony that rests on the balcony railing. The basket is counterbalanced by a body of AW1 as shown in the figure. If the mass of the beam is 3 kg, calculate the weight W1 needed, and part B, the force exerted on the beam at the point O. So from the previous work we're going to do this, and the value of G is 9.81 meter per second square. Now we have mass is equal to 3 kg and W2 is equal to 23 Newton. From the free body diagram, we change the centimeter value into meter, that is from A to O 0.35 centimeter, and from O to B, that is 0.75 meter. The force exerted on the center of gravity W is equal to mg. We have to calculate from O point. Then upward force is the normal force acting upward, and there is an equal and opposite force, that is W is equal to mg from the center of method, that is from W2 to center of gravity, the length is 0.55 meter, and from the center of gravity to the W1, that is 0.55 meter. From the point O to the center of gravity, the distance is 0.20 meter. Now W1 for the y component is minus W1 into 0.75 is equal to give 0.7 minus 0.75 W1. W2 is equal to minus 23, that is 23 into 0.35 into is equal to 8.05. And for the center of gravity, the mass W is equal to, the weight is equal to mg is equal to minus 3 into 9.81 is minus 29.4, and multiplying with 0.20, that gives minus 5.88. The normal force in the upward direction, as it is balanced, the value is 0. Since the beam remains at rest Thus the system in equilibrium, hence del tau to tau naught is equal to 0. So putting the value 0 minus 0.75 W1 plus 8.05 minus 5.88 is equal to 0. Solving that, we give W1 is equal to 2.89 Newton, and part B summation Fy is equal to 0, and minus W1 is equal to minus 23 minus 29.4 plus 9, N is equal to 0, minus substituting the value of W1, that is 2.89, that is minus 2.89 minus 23 minus 29.4 plus N is equal to 0. So then force normal in the upward direction to balance the weight in the downward direction at the center of gravity, that is 55.3 Newton. Now we're going to solve another example. A uniform ladder AB of length 10 meter and 5 mass 5 kg leans against a smooth wall as shown in the figure 5.17. The height of the end A of the ladder is 8 meter from the rough floor. Part A determines the horizontal and vertical forces. The force floor exerts on the end B of the ladder when a firefighter of mass 60 kg is 3 meter from the point B. If the ladder is just on the verge of the slipping when the firefighter is 7 meter under up the ladder, calculate the coefficient of the static friction between the ladder and the floor. There is a picture you can see. The ladder has the point AB and it is tilted. It is attached with the smooth wall on the rough floor. Given is G is equal to 9.81 meter per second square. We have mass m1 is equal to 5 kg, mf is equal to 60 kg. The free body diagram of the ladder is drawn here. From here we can see that sin alpha is equal to 8 by 10 is equal to 0.8, and sin beta is equal to 6 by 10, that is 0.6. From the figure we have the alpha and beta and the normal force drawn by the wall on the ladder. This is n1. The height is 8 meter and the width is 6 centimeter. So at every point the weight applied on the object is m1g. So we have the angle alpha making with the ladder with the horizontal surface, and beta is the angle made by the ladder with the vertical wall, and the force n2, that is a normal force exerted by the ladder on the ladder by the floor. There is a frictional force Fs, and the distance from the wall to the tilted ladder is 66.0 meter. Now we are going to calculate the force. नमक थोड़ी सी डाले ना मिर्ची. We have m1g. For the x component, the normal is 0. For y component, that is minus 49.1. We're going to put the values and get 147. mfg is equal to x component is 0 and y component is minus 589. So by this substituting the value, we get 1060, and 1 is 0 for the x component and y component. For x component that is n1, and for the y component that is 0, and 2 for the x component is 0 and for the y component that is n2, and the total value is 0 in n2, and the torque calculated by the normal force is minus n1 into 10 sine alpha, that is minus 8 n1. Frictional force for the x component is minus fs in the opposite direction, and for y component that is 0, and the torque for that case is also equal to 0. Since the ladder is in equilibrium, thus del summation tau b is equal to 0. 147 plus 1, all the torques are added, so that is equal to 0. So from here n1 is equal to 151 Newton, and for summation fx is equal to 0. We have two values n1 and force of friction fs, so we write n1 minus fs is equal to 0. The horizontal force fs will be equal to 151 Newton, and that is equal to the normal force value. Summation Fy is equal to 0, substituting all the values, minus 49.1 minus 589 plus 92 is equal to 0. So the vertical force in that case N2 is equal to 638 Newton. By solving that we get the value. Consider the ladder still in equilibrium, thus del summation tau b is equal to 0. Substituting the values 147 plus 2, 474 minus 8 n1 is equal to 0. From here we get n1 is equal to 328 Newton. Summation Fy is equal to 0 minus 49.1 minus 589 plus n2 is equal to 0 and n2 is equal to 638 Newton. Summation Fx is equal to 0. So n1 is equal to micro s, n2 that is the frictional force value that is equal to 0, Fs that is equal to minus mu s n2. So we have written here n1 is equal to 328 minus mu s 638 is equal to 0. So mu s is equal to 0.54, that is the coefficient of the frictional force for the wall against for the ladder against the wall. Now moving to another example, a floodlight of mass 20 kg in a park supported by the end of a 10 kg uniform horizontal beam that is hanging to a pole as shown in the figure. A cable at an angle 30° with the beam helps to support the light. Sketch a free diagram of the beam. At part B is the tension in the cable. To find out at part 2 the force exerted on the beam by the pole. Here the value of G is 9.81 meter per second square. Given here you can see the picture here that a floodlight is hanged with the pole with the cable attached to that pole with an angle 30°. We have MF is equal to 20 kg, MB is equal to 10 kg. The free body diagram is shown here. The length of the pole by which a light is attached, the length from the O to the center of gravity, that is 0.5 meter, and from O to the point S which is hanged, and there is another tension T. Total length is L. At the center of mass the total weight is mbg, and from the point where the floodlight is hanged, that is mfg. So the force is mfg, the x component force is 0, the y component force is minus 196, and the total torque is fd is equal to rf sine theta, that is minus 196 into L. mbg, the x component is 0 and y component is minus 98.1. So we multiply minus 98.1 into 0.5 L, that is minus 49.1 L. Tension for the x component is minus t cos 30°, and for the y component that is t sin 30°. So after solving we get TL sin theta sin 30°, sin 30° is equal to 0.5 TL. S is the force from the point O, so x component is Sx and y component is Sy. So at that point uh, the torque is 0. The floodlight and the beam remain at rest, so torque tau naught is equal to 0 minus 196 L minus 49.1 L plus 0.5 TL, that is equal to 0. So T is equal to 490 Newton. For part 2, summation Fx is equal to 0 minus t cos 30° plus Sx is equal to 0. Sx is equal to 424 Newton. And for summation Fy is equal to 0 minus 196 minus 98.1 plus t sin 30° plus Sy is equal to 0. So Sy is equal to 49.1 Newton. We calculated. Now for the part B, therefore the magnitude of the force is S is equal to under root Sx square plus Sy square. So substituting the value of Sx, that is 424 whole square plus 491 whole square whole under root, that gives after solution solving S is equal to 427 Newton, and its direction is given by theta is equal to tan inverse Sy over Sx, and theta is equal to tan inverse 49.1 over 424. After solving we get theta is equal to 6.61 degree from the x axis in the anti-clockwise direction. Use gravitational acceleration g is equal to 9.18. We have a figure A, B, C, D points. Length is B, width is A. The force on the vertical direction is F1, and in the horizontal direction, that is at point B, F2, and at the point C in the third z-axis, that is F3, making an angle gamma. Figure 5.19 shows the force F1 is equal to 10 Newton, F2 is equal to 15 Newton, and F3 is equal to 60 Newton are applied on a rectangle. Side length is equal to 4 centimeter and B is equal to 5 centimeter. The angle gamma is 30 degree. All the values are given here. Calculate the resultant torque about the point D. You have to solve that numerical by yourself and get the answer minus 3.7 Newton per meter. That is the torque. This is the example you have to solve by yourself. You can see a seesaw with the person sitting with the baby girl or a girl. Seesaw consists of a uniform board of mass 10 kg and length for 3.5 meters. Supports a father and daughter with the mass is 60 kg and 45 kg respectively. The mass of the man is 60 kg and the mass of the girl is 45 kg respectively. The fulcrum is under the center of gravity. Determine the magnitude of the force exerted by the friction by the fulcrum on the board and fulcrum by the board in the seesaw. Where the father should sit from the fulcrum from the center, where should he sit to balance the system? We have to find the distance from the central point. So for the force, the value should be 1128 answer, and for the fulcrum length from the center of central point to the sitting point, the distance has to be calculated. You have to do this as previously done, and the answer should be 1.31 meter. Here you can see a picture of pole length height 3.8 meter. This pole is hanged by a street lights at the point B. That pole makes an angle 37 degree at the point DC. A traffic light hangs from a structure as shown in figure 5.21. The uniform aluminum pole AB is 7.5 meter long has a mass 8 kg. The mass of the traffic light is 12 kg. Determine the tension in the horizontal massless cable CD. The vertical and horizontal components the force exerted by the pivot A on the aluminum pole. This is a similar example you previously done with the block with this floodlight being hanged by a pole. You have to find the answer, that is 248 Newton, 127 Newton and 248 Newton. um, you can see a frame of length 15 centimeter and width 30 centimeter, and that horizontal angle with the hanging is 50 degree, and the force is being applied from the right hand to the left hand on the horizontal face, that is F. A uniform 10 Newton picture frame is supported by the two light strings as shown in the figure. The horizontal force F is applied for holding the frame in the position. Sketch the free body diagram of the picture as previously done. Calculate the tension in the ropes as previously done. The magnitude of the horizontal force F. The answer should be 1.42 Newton, 11.2 Newton and 7.20 Newton. You have to take the reference from the previous examples and to solve this and get the answers. Starting with the rotational dynamic problems, we're going to start further problems. Now we are going to do another example. Two masses 2 kg and 4 kg are located at the x-axis and at x is equal to 2 meter and x is equal to 5 meter respectively. Determine the center of mass of the system. It means that the distance between the two uh, mm, the center of mass is between the two masses. It means that from some point origin O, the mass m1 is at the distance 2 meter and the other m2 is at the distance of 5 meter. So there must be the central point where should be the center of mass of the two masses. So the solution is that m1 is equal to 2 kg and m2 is equal to 4 kg. So by the equation of center of mass, we find the point of center of mass at how many distance it lies. So xcm is equal to summation I is equal to 1 to 2 mi xi over summation I is equal to 1 to 2 mi, that is equal to m1 x1 plus m2 x2 over m1 plus m2. That gives xcm center of mass point distance, that is 2 into 2 plus 4 into 5 over 2 plus 4, that gives x is equal to 4 centimeter from x is equal to 0, or 2 m from the mass m1 and 1 meter from the mass m2. Now another example, a system consists of three particles having the following masses and the coordinates. 2 kg is at 1 1 coordinate, second is 4 kg at 2 0 coordinate, and the third is 6 kg at 2 2 coordinate. Determine the coordinate of the center of mass of the system. First mass is m1 kg, m2 is 2 kg, and m3 is 3 kg. The x coordinate of the center of mass is xm is equal to summation I is equal to 1 to 3 mi xi over, and summation I is equal to 1 to 3 mi. That gives m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. That gives xcm is equal to 2 into 1 plus 4 into 2 plus 6 into 2 over 2 plus 4 plus 6, and that gives xcm is equal to 1.83. That is the center of mass of all the three masses. Now to find the determine the center of mass of the system, that is the center of mass at 1.83 meter. Now to find the coordinate of the center of mass, the y coordinate of the center of mass is ycm is equal to summation I is equal to 1 to 3 mi yi over summation I is equal to 1 to 3 yi is equal to m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. That gives ycm is equal to 2 into 1 plus 4 into 0 plus 6 into 2, that or divided by 2 plus 4 plus 6, that gives 2 plus 0 plus 12 over 12, 2 plus 0 plus 12 over 12, that gives 14 over 12, and that gives ycm is equal to 1.17. Therefore the coordinate of center of mass is 1.83 and 1.17. That are the two coordinates. 1.83 is the center of mass at x-axis coordinate, and the 1.17 is at the y coordinate point. Now moving to the problems related to the moment of inertia, we're going to start the next part. Now starting the example problem for the inertia moment of inertia. Four spheres are arranged in a rectangular shape of sides with the two 50 centimeter and 120 centimeter. As shown in the figure, you can see that there are two masses of small two there four masses, and one is 2 kg, one is the other is 3 kg, then the 4 kg and 5 kg. Then we are going to find the center of mass between the all the masses. So we are going to find the common point between the center of mass between the all four masses, that is the point O between the four masses system, and there is a reference line which passes through the center of mass, that is AB. The distance from the 3 kg mass to the point B is 60 centimeter, the half of 120 centimeter, and from the point B to the 4 kg mass, that is 60 centimeter. So the total distance between the two masses 3 kg and 4 kg is 120 centimeter, and half of them is 60 plus 60. So the total distance between the two masses in the width is 250 centimeter. The spheres are connected by light rods. Determine the moment of inertia of the system about an axis through a point O along the line AB. Now the solution is m1 is equal to 2 kg, m2 is equal to 3 kg, m3 is equal to 4 kg, and m4 is equal to 5 kg. Now a rotation axis about the point O. First of thing we have to find m1, m2, m3, m4. The distance between the center of mass and the m2 is in meter is 0.6, and from O to the B point the distance is 1.25 meter. We have converted that distance into half of 250 into centimeter. 250 gives 125 centimeter, and that 125 centimeter converted into meter is 1.25 centimeter, 1.25 meter. Now the R1, R2, R3 and R4 is equal to R. So the magnitude of R is equal to 0.6 square plus 1.25 whole square under root is equal to 1.39 meter, and the connecting rods are light, therefore I naught is equal to m1 r1 square plus m2 r2 square plus m3 r3 square plus m1 4 r4 square. As r1 r2 r3 r4 are common, so we're going to take r square common. I naught is equal to r square into m1 plus m2 plus m3 plus m4, that gives is equal to 1.39 whole square into 2 plus 3 plus 4 plus 5. Solving that gives us I naught is equal to 27 kilogram meter square. That is the inertia of the system. Now the solution is m1 is equal to 2 kg, m2 is equal to 3 kg, m3 is equal to 4 kg and m4 is equal to 5 kg. Now the part B, rotation axis along the B line AB. So we have the distance between A and m1, that is r1, and m2 and B point is r2, and from B point to m3 that is r3, and from A point to m4 that is r4. R1 is equal to R2 plus R3. R1 is equal to R2 is equal to R3 is equal to R4, that is equal to R, and that is 0.6 meter. Therefore, we are going to find the inertia AB, that is m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. Taking r square common, we have IAB is equal to r square into m1 plus m2 plus m3 plus m4, that is IAB is equal to 0.6 whole square into 2 plus 3 plus 4 plus 5, that gives IAB is equal to 5.04 kilogram meter square. That is the inertia along the line AB, rotational axis along the line AB. The problems are here. The further we'll discuss in the next lecture. Now moving to the next point, that is, these are the references for your classical mechanics. You can get help with this. Hopefully the topic under central forces we have discussed is very understandable to you. If there is any kind of difficulty, you can ask me. Thank you. Is there any kind of difficulty? You can ask me the question. Hopefully the whole topic with the starting with the central forces in classical mechanics is very understandable in the lecture. Thank you so much.